In this video, I'm going to explain how to calculate average delay related to lane change problem. So there are two set of problems here. I'm first going to go over number A and then go over B. So in A, it says, in a two-lane, one-way stream of 1,000 vehicles per hour with 300 vehicles in lane A and the remaining vehicles in lane B. 8% of the vehicle in lane A have gaps less than 1 second, and 18% of the vehicles in lane A have gaps less than 2 seconds. Compute the time during which vehicles in lane B may not change to lane A in an hour. Assume driver requires 1 second ahead and behind in making a lane change. So what this is asking is that it's basically asking to calculate the times that drivers from lane B cannot change to lane A due to the short gaps. So the equation here is pretty simple. So total acceptable time for lane change in an hour is equal to 3,600, which is 1 hour in second, minus rejected headway, and clearance time. So clearance time is when drivers need to clear out before they actually make changes, make a lane change. So right here in the problem, it says assume driver requires 1 second ahead and behind in a lane change. So it'll be 1 second ahead and behind. So it'll be 2 seconds per gap for acceptable gaps. So let's go over the question. So there are two lanes, A and B here. So the question said there are 1,000 vehicles per hour, but it said 300 vehicles in lane A, and then remaining on B, which is 640 vehicles. So I'm first gonna calculate the rejected headway. So rejected headway includes the gaps less than 2 seconds where drivers could not make changes. So I'm gonna write it here, rejected headway, gaps less than 2 seconds. So in the question, it say 8% of the vehicle in lane A have gaps less than 1 second, and 18% of the vehicles in lane A have gaps less than 2 seconds. So I'm gonna calculate how many gaps are there associated with it now. So right here, gaps less than 1 second, and then 1 second, gaps between 1 second and 2 seconds. So it'll be 8% of the vehicles in lane A. So times 360, and this will be 18 minus 8 because it's between 1 to 2 seconds, percent times 360 gaps or vehicles. So if I put this in the calculator, it'll be 0.08 times 360, which is 28.8 gaps, and then this can be rounded to 29 gaps, and this right here, it's 10% of the 360, so it'll be 36 gaps. So in total, there are the total number of unaccepted gap is 29 plus 36, which is it is, what is that, 5, 4, 65 gaps. And however you want to convert this into second, because headway right here is we have to calculate the acceptable time, total acceptable time, and headway is in second here. So what I'm gonna do is this 29 gaps times by 0.5 second, because this is the average between 0 to 1 second, and this is times by 1.5 second. So this is 14.5 second, and this is, let me put this in calculator, 1.5, this is 54 second. So total rejected headway equal 14.5 plus 54 second, which is 68.5 second. So now I'm gonna calculate the clearance time, which is 2 seconds per gap. So let me write clearance time 2 seconds per acceptable gaps. So acceptable gaps, and here we already calculated the unacceptable gaps previously. So total number of unacceptable gap is 65 gaps. So we're gonna subtract that from total and get acceptable gaps. There are a total of 360 gaps in lane A minus 65 equal 295 gaps, acceptable gaps. And we're gonna do times by 2 seconds, which is the clearance time per lane change, and this is 590 seconds. So we got rejected headway and clearance time. We're gonna now calculate the total acceptable time. So total acceptable time is equal 3,600 minus the rejected headway is 68.5 minus 590 equal, let me put this in calculator, 0.5. This is 2,941.5 seconds. So this is the total acceptable time for the lane change in an hour. This is right now in second, but you can also put it into in percentage, which will be 241.5 divided by 3,600. Put this in calculator. So it is 81.7%. So 81.7% of the time, driver from lane B can change to lane A in an hour, and the times that drivers cannot make changes will be 306 minus 241.5 divided by 306, which is equal to, let me put this in calculator, it is 18.3% of the time they can't make changes. So we got number A. Now I'm gonna jump to lane the number B, which is pretty simple using the formula. So it says assume that the average traffic stream speed is 50 miles per hour on lane A, and the speed on the lane B is 40 miles per hour. Estimate blockage length and average delay due to lane change. So these are the equations right here that we're going to use. So blockage length is equal to T times Vs divided by N. So T here is total time subject vehicle is prevented from changing lanes, and VS is stream speed. So they're changing to lane A, so it'll be 50 mile per hour that we're gonna use. And N, we already calculated that in the previous problem. And average delay here can be calculated by 1/2 times blockage length over VR. VR here is the relative speed, so it'll be 50 minus 40, which is 10 mile per hour. So let's calculate this. B. So first I'm gonna calculate blockage length is equal to T times VS divided by N. So we already calculated all this earlier. So T is total time for subject is prevented from changing lanes. So it will be, let me write it, T will be 3,600 minus 294.5, which is 658.5 second, and or you can calculate it as a rejected headway plus clearance time. So rejected headway here is 68.5, and then clearance time is 590. It's the same thing, 668.5 plus 590 equal it's the same thing, 568.5 second. And VS here is 50, so let me put it in 658 times 50 mile per hour. And for N, we also calculated N earlier. N is a number of acceptable gaps. Acceptable gaps is 295. So divided by 295 gaps. Let me put this in calculator. 658 times 50 divided by 295 is 111.5. Is the blockage length. And then I'm gonna now finally calculate the average delay. Is 1/2 times VL divided by VR is 1/2 times 111.5 divided by VR is 10 mile per hour. So let me put this in calculator. That's 5. So it'll be 505.8 seconds. So there are on average 5.58 second delay per lane change.